So gyaniki vandu oru research and repository site. Okay. So gyaniki na associate பண்ணி கொஞ்ச நாள் ஆகுது. Undertakes specialized, what you say, customized research. Okay. In areas where the future mobility is concerned. இப்போ future mobility ல வந்து customized ஏரியால research பண்ணிட்டு இருக்க ஒரு team gyaniki. Okay. Okay. So some people are asking that I have to use English. Okay, fine. Okay. So as for gyaniki, if anybody wants to have Tamil, please. Okay. So as of gyaniki, the site actually, or the repository of gyaniki is so diverse, and it also includes a lot of people and a lot of information regarding the what you say, ecosystem, basically, where the manufacturers, tier 1 suppliers, tier 2 suppliers, etc., are being came to a single platform. Okay. Now you will get almost all the informations you want from the site. If you are a manufacturing guy or a OEM who wants to expand your supply chain, gyaniki will be helpful for you. Okay. Now, as of regarding me, I'm just a technical trainer and consultant in automobile sector. So I'm basically an automobile engineer in the first place. So I done my diploma and BTech in automobile engineering. My master's was in industrial. Been working as a technical trainer and consultant for device electronics for the last 2.5 years or more. Worked with multiple companies in different projects. In BS6 also, BS6 transition also, I worked with some companies. I worked with German companies, particularly in heavy commercial areas. Yeah, to a certain extent, that's my portfolio. Anyway, I know you guys are not here to hear my boring portfolio. So let's move towards what our topic of today is. Okay. Is my screen visible?
Yeah, Jinesh. Yeah.
Okay. So our topic today is about the trends in electric vehicles and battery packs. Okay. And I don't have to tell you that the electric vehicles are growing in demand, particularly in Asian market. Okay. We don't have to look anywhere else because we are living in the Asian continent. So in Asian market, the requirement for electric vehicles are increasing, and it's not a wonder to understand why it is increasing, because in India itself, the electric vehicle market just exploded, particularly in three-wheeler area. So overall, in 2024 compared to 2023, it just increased by 25%. So we call 5% as significant. This is 5 times the significant value. So 17.1 million EVs additionally sold, like completely sold in the Indian market, and sorry, global market. And in India, one thing is really wonders me, like the three-wheeler industry is heading the what you say, is taking the baton. So the three-wheeler industry is absolutely going electric. As you can see from the right side graph, the EV sales numbers are growing so high, it just, even the remaining parts, two-wheeler, buses, cars, all of them together cannot match the three-wheelers. So this is something that we don't see often. Okay, in terms of number, it may be electric two-wheelers because we are particularly a two-wheeler country. 50% of the total vehicle sales is two-wheeler. So it's not a wonder that the numbers are high in two-wheelers, but penetration-wise, the two-wheeler, how many electric vehicles are sold per 100 vehicles. That's what we call penetration. The penetration is comparatively lower in the electric two-wheeler market, and basically it's due to majority of the electric two-wheelers are scooters, and scooters are city dwellers. You don't use scooter as a long distance vehicle. Most of these things are what you say city dwelling vehicles. So these are used for small application. While buses, yes, buses outsmart the four wheelers in terms of the kind of penetration because the bus is supported by government. Majority in global area also in Bloomberg study in 2024, two-wheeler and three-wheeler takes the first in global market penetration, and then the buses. I believe 37 percentage or 36 percentage of the global sales is buses. That means out of 100 buses sold across the globe, 37 are electric. While two and three wheelers, it's somewhere near to 48, 49 percentage. That means half of the two wheeler and three wheeler sold across the globe is electric. While the passenger vehicles, if I remember correctly, the passenger vehicle sale is just 14 percentage, 14 percentage. So you can understand electric bus sales across the world is more than twice that of passenger car sales. And what is the lowest is heavy commercials and vans, means delivery or passenger vans. So that's somewhere near 3 percentage or 4 percentage. So that's the condition across the planet. But in India, we have seen a huge surge of electric vehicles. Now, if you consider the electric passenger vehicles, 2025 is the most deciding year where you will see around 15, 1 5, I say, 15 different electric vehicle models launched by various companies. That's more than that of ICE vehicles that is planned to launch. So you have more electric vehicles coming out of manufacturers, various manufacturers this year in Indian four-wheelers than a combined IC engine vehicles. So almost all the manufacturers in India are betting big numbers in electric vehicles and they just want to go to electric vehicles, not to hybrid vehicles. Maybe Maruti will be a different terms, but other than Maruti, everybody wants to bet in electric vehicles. Okay. Now I don't have to tell you what are the components in electric vehicles. So the first component is of course your battery pack, particularly high voltage battery pack. And everybody knows that it is just a fuel tank. So you store your fuel inside a fuel tank, and for an electric vehicle, your fuel is electricity or electrons, you can say, and you store the electricity inside your battery pack. So it is a big fuel tank. The only difference is it is the costliest, it is the heaviest, and it is the largest fuel tank in a vehicle. And then you need the fuel control system where you control the electricity, channels the flow, etc., etc., etc. So that's what we call the power electronic devices. And then you need to convert the electrical energy into mechanical energy. And that's where the engine comes in, or electrical engine, just like the American peoples call. Yeah, American peoples have different what you say acronym for everything. They call the electrical motor as electrical engine. So to some extent, it is relatable. So it just convert the electrical energy into mechanical energy. So these three are the powertrain components, you can say. And then ultimately you need the low voltage systems in the vehicles. So if you are in a four-wheeler or LCV or LMV, maybe up to medium commercial vehicles in India, it's 12-volt system. You have a 12-volt battery which runs your headlight, wipers, instrument clusters, all this blah 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 stuff. And then you have medium commercial vehicles, sorry, heavy commercial vehicles, which runs on 24-volt systems. So this low voltage system is what controls your high voltage system. So people sometimes forget that all your ECUs, electronic control units, are controlled by the low voltage. These are low voltage components, whether it is BMS or motor control units. All these are low voltage control devices. Okay, they control the high voltage. It's not the high voltage system controls the low voltage. It's completely opposite. So if you don't have a low voltage system, it doesn't matter whether you have a 100% charged battery. The vehicle is as good as a dead horse. It's not going to move. Okay. So just to remind you what are the things in an electric vehicle, you have a battery pack, and then from the battery pack it goes to a PDU, and then goes to the main component, of course, is the inverter and motor controller, and ultimately the motor controller converts it into uh, alternating current and runs the what you say motor. So yes, this differs in low cost two wheelers where you have BLDC motors for the cost advantages, price advantages you can say, because AC motors are better in every terms with respect to DC motors, while DC motors are cheaper, but they are less efficient. So you will see AC motors from a performance and efficiency perspective in majority of the high premium two wheelers to all the way up to heavy commercials. So you have battery pack PDU, motor controller or inverter basically, and the alternating current motor. And then you need to charge your LV battery because you have an LV battery. Battery cannot produce electricity. It just store the electricity, so you need to charge it. So this is your alternator in that sense. So what the alternator do in an IC engine? This is the component that do the same job. And then you will need an AC compressor for a car. This is what I'm saying, car or LCVs. You need an AC compressor which do your battery cooling and passenger cabin cooling. You have maybe it's an optional stuff in India. You may have a heater for battery heating or cabin heating. Okay, and then you will or most of the LCV segment, I believe you will have an onboard charger. Heavy commercial vehicles, it's an optional because the size of the onboard charger is too much to handle. So majority of the heavy commercial industry sometimes neglect this onboard charger and just go with the DC charging only. So charger on board, that is what onboard charger is. Charger inside the vehicle. If the charger is outside the vehicle, then it is off board. For example, if you buy an Ola or Ather, you get the charger in your hand. So that's an off-board charger. So while if you buy the Chetak 35 series, 3501, 3502, 3503, the charger is inside. So you only have to carry the cable. So that's what we called on-board charger. The charger is on board of the vehicle. Okay. Now, this, to give you an understanding, this is how the first generation Nexon EV looked like. Okay. So the first generation Nexon EV was a car we have to give credit to because it was the one that started the electrification in automobile industry. Purely speaking, this one or Tata Nexon was the risk taker or the market opener in electric vehicle industry where people started to put their money for electric vehicles. And you can see all the three components here. Okay, let me take my pointer. So what you see at the top is the PDU, which is this, and you have a DC-DC converter. Then you have an onboard charger. So all these components were separate. Now, this was in, I believe, 2018 or 2019 in the beginning. But the world just moved on because when you understand electric vehicles, you understand electricity. And when you understand electricity, you will understand higher the number of cables, lower the efficiency, and higher the cost. Okay, because you always have conduction losses. And as a result, the present system is the engineers are actually thinking, okay, how can I reduce the number of wires? How can I reduce the coolant loops? So then they understood, okay, let's combine the components together and put them in a single cabin or a single container. And the PDU onboard charger, and DC-DC converter has been merged into a single entity, and we call it as the power distribution module. And the rest of the stuff is the same. If you consider the rest of the stuff are same, since the, the single power distribution module or PDM is controlling everything, the number of wires are reduced, the number of coolant loops are reduced, and as a result, the total resistance of the high voltage harness is reduced. So when the resistance reduces, you can understand that the heating losses, which is called the Joule's heat, the equation I believe at least everybody know H is equal to I square RT, has been reduced drastically. So the resistance is directly proportional to length of the conductor. So lower the length of the conductor, better the efficiency is. Not only that, the high voltage cables cost a huge money, and you don't want a too much amount of high voltage conductors inside your vehicle. So the architecture is very critical. And this is how the system looks like in the modern vehicles. Whether you take Mahindra, whether you take Tata, instead of separate PDU, DC-DC converter, etc., 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 what you're going to find is the PDM. I think the Mahindra call it as the IPDM, Intelligent Power Distribution Module or something like that. Basically, Tata and Mahindra uses the same company. I think it's Value's Power Box, HV Power Box is what they use. So it combines the PDU, what you say, the onboard charger, DC-DC converter, etc. And that just minimizes the total amount of wiring requirement. It took very less space to occupy. It just need one coolant loop. So less amount of coolant pipes, less amount of coolant also. So weight reduction and component reduction is really a matter of concern in electric vehicles. Now, this is a dual motor version of electric vehicles. Now, all-wheel drive in an electric vehicle is absolutely simple to understand. You just put a motor in the back, just put a motor in the front, and with that, you already got a four-wheel drive. And this is the Hyundai Ioniq 5. I think Hyundai Ioniq 5 don't have four-wheel drive in India. Instead, its sister concern, which is the Kia. The Kia EV6 comes with a all-wheel drive, which has a front motor and a rear motor, but both are on the same platform. I think the TNGP platform. So you have the battery pack in the middle, and connected to the battery pack is three, which is the ICCU, which is a combination of onboard charger and DC-DC converter, as you can see. Then you have the rear motor, okay, which is an e-axle. We'll come to the e-axle later. Okay, then you have a junction box here and a junction box at the front. And you have front motor, which again, sometimes it is activated, sometimes it is switched off. So what everybody thinks about electric vehicle is, okay, the electric vehicles are too costly. I have some questions coming. I think Prashant shared me some questions. Out of which the electric vehicles are costly nowadays, and the petrol vehicles or diesel vehicles equivalent are less costly. And we have to understand one factor, that the battery cost is the major cost of electric vehicles. Somewhere around 30 percentage to 40 percentage of the total vehicle cost is for the battery, as you can see from this figure clearly. Now, this is in 2020. I have to remind you that in the 2020 time period, the battery cost was higher than today. And the vehicle cost was as per the TPEM. I think the Tata Passenger Electric Mobility, the CEO, Mr. Anand Kulkarni, said in an interview that the peoples have to pay somewhere around, or they are ready to pay 1.3 times, that is 30 percentage more for an electric vehicle. So if you are paying 10 lakh for an IC engine vehicle, equivalent electric vehicle will cost you 13 lakh. That's what 30 percentage more means. And that is mainly because of the electric battery and the powertrain. But what we going to see at the end of this year or maybe 2026, you don't have to wait for 2030, is this, where electric vehicles are marginally pricier or there will be a price parity. TPEM, I think the Tata Passenger Electric Mobility, they said in an interview this year or last, I think the last year, maybe May or April, they said in an interview that by 2026, there will be some price parity in mass market electric vehicles. So mass market electric vehicles for Tata means it may be the Tiago, maybe Punch, maybe Nexon. These vehicles may going to reach price parity with their IC engine models. So that means you will get a Tiago EV for the same price of a Tiago IC engine. May not be the base price of an IC engine, but maybe the middle variants will be matched. So Punch, which is now starting at 10 lakh rupee, may start maybe at 8 lakh rupees, maybe at 2026. Nexon already dropped in its price, but it may go down to 10 lakh or 11 lakh rupees. So who knows? So this year will be a fantastic year, and I'm waiting to see more models, and the competition is going to be higher. So as the
Dinesh,
competition
any
is,
updates regarding the Suzuki vehicle? Suzuki, any updates regarding the EV model in Suzuki? How they going to bring down the price and have a competition with Tata? Any updates if you have, please let
uh,
us.
see, Suzuki, it's a wonderful proposition, but again, consider it as my personal opinion. I visited the Suzuki dealership to understand the vehicle. I haven't driven the vehicle, but I checked the internals. So what you see as the PDM, the Tata and Mahindra uses the value PDM, while I believe the Suzuki is still using the Delta, which is huge in size. It's literally huge. It's comparatively very big than the value. And there is no frunk, even though the platform is made by Suzuki. And we all know that Toyota and Suzuki is, they are brothers in majority of the cases. For the last 10 years or 20 years, almost all the automatic transmission Suzuki used came from Toyota, ISIN transmission, still uses ISIN transmission a lot. And
Yeah,
they actually displayed the e-Vitara, and the battery comes from BYD.
blade battery.
The yeah, the full blade battery. Unlike the Mahindra, it's full blade battery. I will show you the battery. The problem is, I don't know where they're going to price it. The if the rumors are correct, they're going to price it in and around 20 lakh to 25 lakhs area. But as of now, the market is again below 20 lakhs to 23 lakhs, where you can see the Creta is placed. So if e-Vitara comes there, so many peoples are going to go for it because the trusted name of Suzuki is there. And
Yeah,
people wanted always a trusted name. Out of all the Indian manufacturers, Maruti had the least reliability issues. And that's a reality. Consider Tata,
the
Mahindra.
service availability compared to
Yes,
Tata.
exactly, exactly,
Service.
exactly. You take a Tata vehicle and go to a service center, and it's not going to be a very pleasant situation always. But on the contrary, you have what n number of service stations for Suzuki, and means Maruti Suzuki. Presently, it is only Suzuki. So people have little bit more trust towards the brand, and it is always a reliable brand. I don't think you can say it's a safer brand, safest cars, but yeah, it's a reliable car. Ultimately, a reliability is also matters. So we have to see how they're going to place, because we saw how they placed the Jimny. Jimny was
Yeah,
a capable car and they overpriced it, and now they can't sell it. So
yeah,
we have no understanding how Maruti is going to place this vehicle. So I reserve my opinion regarding that. But personally, I didn't enjoy the vehicle too much. Uh, Again, my wife is also not very. She also not felt in the back. She was also feeling that the floor height is little bit higher. Maybe once the test drive comes, we'll have a different opinion. But until now, it's just a rough opinion. So I'm not pushing it to that. But yes, there is a car, electric car coming from Maruti called e-Vitara, and based on that, uh, the Toyota will introduce the electric urban cruiser. I think the urban cruiser has a little bit better face than the e-Vitara, but again, that's a different opinion. That's my personal opinion.
And also this, the Wagner also going to come for the market, electric Wagner or some. They have
Ah,
made in market. They're going to made in market. 2027, I think so. Exactly the date not yet fixed, but Wagner is going to come, I think so.
See, electric Wagonar's been tested in India for around, I think, 2017 to 2018. If you see a lot of spy photos, or they actually tested the electric Wagonars in India for a long time. And if you go to Manesar, there may be at least 100 Wagonars in their factory. But I
Yeah,
don't know what is going to happen with the present generation Wagonar because the presently selling Wagonar, the Wagoner, I think the fourth generation or third generation, it's based on the Ignis platform. Uh,
yeah.
so that's a Ignis. Basically, it's Ignis underneath, and it's not the old Wagoner. So what the problem is, if you want to retrofit a car, just like this picture you see, it's an electric Golf. Placement of the battery pack is going to be a real challenge. So
Yes.
you can understand that by looking into Tata Tiago or Tata Tigor, where you don't have a spare wheel. Of course, for Tiago you don't have a spare wheel because the spare wheel and the fuel tank area has been modified to place the battery pack.
Yeah.
While the Tigor you get the spare wheel, but it is in your boot, so you
Mm.
suffer with your boot space. Remaining stuff is okay. For the engine compartment was already there, so all the stuff can be packed there. It's the battery and routing of HV cables. You need a long routing systems, etc. So you have a lot of troubles with converting an existing IC engine to battery electric vehicle. Yes, but I definitely wants to see the Maruti Wagner because it's a good city car and it's a part-time highway cruiser also.
And also this
uh,
espresso also going to place in EV, I think so. They are
uh,
planning for EV espresso
so
vehicle.
I never, I was not even a fan of the espresso. It's a half-hearted. It's a nano SUV. You can say it's never. Maruti never advertised it. If you really see the way they work, I think somebody in Maruti thought, okay, we need an SUV and we need to put it in the lowest cost. So they just altered the, I think the Celerio platform or the Alto platform and put a SUV on top of it. And when that comes, I simply think why Maruti even tried making something like that.
I don't know
It's
because they are good at IC side, so they think
yeah,
that
it's
we can.
they are fantastic in IC side, and one of almost their K series engines are so reliable. Their present generation, the K10C and the K12C, they are fantastic engines. The K10C, particularly the dual jet engines, K10, K12C, I like it. Uh, I don't like the K15C, but I do like the K15B, which is presently in the Jimny, which was in the old better Abrasa. But I don't know how they're going to perform it in the electric vehicle because making an IC engine is one step, making an electric vehicle is a completely different step.
And
While
also Suzuki and Maruti will push this in hybrid mode, I think so, because they are planning
uh,
for more hybrid.
yeah, definitely,
Hybrid.
that's what I said it in the first place. Suzuki and Toyota, being brothers of the same arms, they Toyota bet a huge money in hybrid vehicles, and Suzuki also had a hybrid vehicles. I think the P4 systems they already have. So If you search the YouTube, you will find Suzuki hybrid vehicles where the motors are connected on the transmission end. So there is a possibility the C series engine, which is in the C12, I believe, which is in the Suzuki Desire and the Suzuki Swift, is of very high efficiency, and it is most commonly going to be the hybridized platform of Suzuki. It's a
Yes.
three-cylinder engine, naturally aspirated. It doesn't have a turbocharger, and it has that attributes. So I believe that engine will be going into hybridization in the later period. Maybe at the end of this year, we may going to see a hybrid version of that engine. But electric platforms, I don't know how much they developed a small car platform. Presently, nobody except Volkswagen showcased a what to say a good small car platform. I think the last week Volkswagen showed the ID1 everyone or something like ID everyone. It was a good Polo-like car which can actually be your first or the only car in the family, because making a electric car, Nissan know the equation very well, because Nissan Leaf was the first uh, budget family electric car in Europe and America, maybe Japan, Europe, and America. So placement of this battery pack is going to be the biggest challenge. So for a Wagoner, yes, there is a possibility because it is a tall boy design, but I don't know how much the floor has to be altered, how much the space is going to be utilized, what is the battery pack going to be. But yes, I would like to see the Wagoner in electric format. But uh, coming to Maruti again, we cannot predict anything. Unlike the other companies, it's a volume seller. So until or unless it
Again, this
finds
Tata will come with electric nano, I think so. The next year they are planning, I don't know exactly what is the date. They are also planning for electric nano, which with different design and a different model. They also
See, I think by the development time, Nano had an electric model in the past. Okay, not the JM Neo I am speaking. Uh, I don't know how many of you remember the UK Auto Expo where Tata showcased the Pixel. There was a model called Pixel for Nano series, and there was a three-cylinder engine also for Nano in UK Auto Expo. But Tata actually had an idea to do the job with Nano. But as of now, I don't know how much there is a plan, because you need to start manufacturing the what you say mold, the jigs, and you need to start retooling your factories for nano production. So as of now, we are not hearing anything regarding a retooling event, supply chain establishment from Tata Motors. So I consider the Nano as a rumor until we get a solid proof,
yes, yes,
because
yes.
all the old Nano mold and the jigs, the supply chain has been gone. It's been gone. So that plant is completely retooled for the Tiago and Tigor nowadays. So coming into battery packs, basically what you see is an electrochemical cell. And when you open a battery pack, what you're going to see is an electrochemical cell. In your remote also, you have electrochemical cells. And ultimately it goes to a battery, and multiple cells contribute to a battery, and multiple batteries contribute to a module, and module contribute to a pack. And this is what a battery pack is. It's that simple. So a battery pack is a very simple entity. So you take an electrochemical cell, create a battery with multiple cells, and with multiple batteries, you go for modules, and then from modules, go to pack. And you get multiple types of cells like cylinder, prismatic, and pouch. And we can see a lot of cylindrical cells, particularly Tata Motors was a cylindrical cell king. The Taco battery packs are particularly cylindrical cells, long cylindrical cells, I will say. Tesla is a mainly Tesla particularly enjoys the cylindrical cells than the prismatic cells they purchase from China. While if you consider the Hyundai Kia, being so much enthusiastic on pouch cells, particularly all the South Korean brands, if I say, they are one of the most enthusiastic in terms of pouch cell. We also seen pouch cells in the XUV 400, but presently I think the world is shifting towards the prismatic cell, and there is a certain reason for that also. Number one, the cylindrical cells, of course, you are going from 1865 because in 2008, if I remember, 2008, 2009, Tesla Roadster, the first car from Tesla Roadster launched with the 1865 cells, and it was 3.6 volt and 3.5 ampere, means 3500 mAh, I believe, from LG Chemicals or LG Energy Solution nowadays. Then by 2012 or 14, they shifted to 2170, which is a bigger cell. So it's 21 millimeter or 2.1 centimeter in dia and 70 millimeter in height. So the number actually represents the geometrical dimensions. Now they're going to shift it to 4680. So 4680 being a bigger cell, as the cell size increases, the ampere capacity increases. So you can actually have what 20 ampere, 25 ampere, which is 2500, sorry, to 25,000 mAh in 4680. So less number of cells are preferred nowadays because higher the number of cells, battery manufacturing cost increases because that much amount of connections you have to make, that much amount of voltage measurement you have to do. There is a lot of complexity associated with battery manufacturing. While cell manufacturing, it is completely opposite. Higher the number of cell you produce, lower the cost of the cell. So a cylindrical cell has the lowest cost because the production rate is too much and it's a matured design. I think the manufacturing design is very matured. But you have to understand you can only manufacture one type of cell in one method. Okay. While the prismatics, you have the adjust, what you say, flexibility. You can make it bigger, you can make it smaller. And when you make it bigger, you have a higher capacity. So that gives you the flexibility. So whatever the capacity you want, if you want 200 Ah, 300 Ah, 500 Ah, it's the prismatic that serves you better. And that is one of the reason why nowadays everybody wants to go to the prismatic cells. Okay. So you take a cell, you connect them into module, then put it in a battery pack. So a prismatic battery contains less number of cells, and less number of cell contribute to less welded joints. Less welded joint mean less failure modes and less quality problems. But it also comes with its own challenges. But yeah, in terms of battery manufacturing, prismatic cells has this advantage. You can see the prismatic modules of Audi and prismatic battery of Mercedes-Benz here. Okay. While the pouch cells, we are familiar with pouch cells in our mobile phone, laptop, etc., etc. As I already told you, South Koreans like LG Energy Solutions, SK, they are betting very high on pouch cells. Uh, these are laminated aluminum foils inside which you have cathode, anode, and separator. Uh, you have to be very careful with these pouch cells because pouch cell has the least safety items in terms of cell manufacturing. You don't have a vent plug. You have a lot of gassing issue. You have to compress them. There are a lot of issues regarding the pouch cells, and they are completely non-standardized cell. You cannot purchase them with a particular cell size like a, cylindrical cell. You can go around the world and purchase any 2170 cell, and most of them will fall into your category. While
Dinesh,
pouch
can
cell,
you please
yeah,
explain about the blade, battery, and cells because people are asking about that. Can you
okay.
explain?
So basically, you have two types of chemistries. One is NMC chemistry and one is LFP chemistry. I believe you know that. So most of the companies in India are choosing the LFP chemistries, except for the South Korean. The Hyundai is still in NMC. I'll come to that. So presently we are in the cathode chemistry as NMC and LFP, while anode is mostly graphite, where in mobile phones you can see the graphite is getting doped with silicon. So silicon anode or siliconized anode is coming to increase the capacity. Okay. So as we progress from a generation 0 to generation 3B, or presently we are in generation 3A, we are going to go for generation 3B. Somebody was asking it out or what?
Participants, if you have any doubt, please table your mic and put the question.
Please put it in the chat, or it will be helpful for Aravind to track the questions. Okay.
Sir, my opinion is first to complete the presentation, sir. Then we ask a question. That's a
Okay.
better way.
Yeah. Okay. No problem. Thank you. So presently, if you consider the mid-nickel batteries are coming back. So what I take it as a mid-nickel battery is there are NMC batteries, and with respect to the NMC battery, there are NMC 532, NMC 523, NMC 622. These are called the mid-nickel batteries or medium nickel batteries. Okay. Now the price of the medium nickel batteries are fallen over the years because very high amount of lithium-ion batteries, sorry, LFP batteries came into the market. The Chinese market was literally flooding the industry with LFP cells. And as a result, the medium nickel batteries were fallen in from the original price point. And this gave the opportunity for the South Koreans to cut the price and put them instead of LFP battery. And this is what we see in the new Creta. So the new Creta is a mid-nickel battery, and Hyundai actually told it in their CEO investor meeting that they're going to invest in the mid-nickel battery for their budget vehicles, and also they're going to invest in LFP battery, and they're going to invest in high nickel batteries, higher nickel batteries like 721 or 712 or 811. They are called higher nickel batteries. They have a higher nickel components. So they're going to invest in higher nickel batteries for their performance vehicles. So you're going to see a lot of medium nickel batteries in the coming years for maybe the two-wheelers, three-wheelers, and budget vehicles from foreign players. While if you go to the cells, what the most funny thing is, presently the world is looking towards this particular stuff, which is called the lithium sulfur battery. And the irony is the lithium ion battery, the first lithium ion battery with a lithium cobalt oxide came in 1970, and the first lithium sulfur battery came in 1968 or 69. Now, the companies that are working on this is two particular companies. If you want to focus, is the Lighten, again a American company where Stellantis invested. So they manufacture the lithium sulfur battery because the lithium sulfur battery has a very high energy density. So per kilogram they can store 550 watt, and that's nearly double that of a normal NMC battery. Okay, even if you take an 811, somewhere in the vicinity of 250 watt hour per kilogram is NMC 811. Lithium sulfur is more than that. I can say 200% of that. But there is a problem. The cycle life is comparatively lower. The cycle life is said to be 1000 to 1500. Again, until we get it in the automobile application, we have no idea what this company has done. The second company is the Sita Energy. Again, it's a US company. This is also invested by Stellantis, and it has an Indian connection. So Sita Energy actually had a tie-up, or they are in an MOU with the Log9, LOG9 in Bangalore. Bangalore-based Log9, which is an again a battery manufacturer, has a connection with Sita Energy, and you can see there are pouch and prismatic and cylindrical cells coming out of Sita Energy. So maybe we will see a lithium sulfur battery made in India by the technology transfer later this year. Then coming to sodium-ion batteries. Sodium-ion batteries, I believe everybody know the sodium-ion battery. It's older, it's cheaper, but the problem is it's heavier. So there are three companies in China particularly working on sodium-ion battery. Sodium-ion battery has its own advantages. Number one, it's safer. It has fast charging capacity. It can work at low temperature. It can be discharged to 0 volt for transportation. But the main problem still the sodium-ion battery has to figure out is the energy density. That means a lithium iron phosphate or LFP battery is in the vicinity of 160 to 170 watt hour per kilogram. And the first generation sodium ion batteries presently available are 140 something, 140, 130. That is the kind of energy density you have, which means you need to put more batteries in the system. So this is a problem for automobiles because when you use a sodium ion battery, the battery pack size increases, the battery pack weight increases, and weight is an enemy of automobiles. But a sodium ion battery is a fantastic battery for energy storage application because the cycle life is nearly maybe 20 percentage to 30 percentage more than LFP. So until the mass manufacturing of the sodium ion battery starts, we may not see the price parity or price difference. But the Chinese companies are forcing themselves into sodium ion batteries. And the CATL, which is the largest battery manufacturer in China, they invested in a sodium ion battery and they going to release their second generation sodium ion battery maybe this year or next year. And they also proposed a hybrid battery with LFP. So you have sodium ion batteries and LFP batteries inside the battery pack. And you will have BMS that is capable of measuring the or balancing the two battery chemistries. So it been proposed by CATL in I think 2021 end or 2023 or I don't remember the exact number of exact year, but I believe it is in 2023. They proposed this kind of hybrid battery packs and they are working on it. The fact is they are working on the Chinese companies are working on this thing. And then other Chinese
Any
companies.
what about zinc ion batteries? Any updates from the OEMs in India, whether in which vehicle they are going to make zinc ion batteries?
Zinc ion battery is actually older than the sodium ion battery, but the problem is zinc comes with its own challenges. So there are some electrochemical reactions in the zinc ion battery that we are not particularly able to contain it. So application wise, zinc ion battery may take more time to get into automobile industry because sodium ion batteries are now getting tested in the automobile industry. So once the testing is finished and the production starts, we may see the sodium ion battery in the near future. But zinc ion battery, it may take even further because it is still in the pipeline. It may have the advantage of cheaper cost because zinc is something that Indians actually produced. In the medieval period, everybody was asking for a zinc and India was the only producer. So we mastered the production of zinc way past in our history. But presently, if you say the zinc ion battery, it's not up to that level of technological advancement where you can actually use it in the automobiles. While sodium ion batteries, these companies, the BYD, the CATL, and the HINA, they are in that category. The HINA says their second generation sodium ion battery are equal to LFP batteries. So if that thing really happens and the production rate goes to 1 gigawatt hour like in gigawatt hour scale, then you may see Chinese companies switching towards the sodium ion battery because lithium is a hard to get metal compared to sodium. Sodium is readily available, and if you can really use sodium, it's easy. But it's not that easy to put the sodium. And in India, Reliance is invested in a company, I believe UK company or Israeli company, I don't know. It's called Faradin. They invested in this company, Faradin, Faradin, I believe. They are in the research of sodium ion batteries, and in the Jamnagar Giga complex, something like that. Jamnagar Giga Green complex, 1,000 acre is allotted to manufacture the sodium ion batteries. So maybe in the future we will see a lot of sodium ion batteries in India. Okay.
So the sodium air battery also we are using, right? Sodium air batteries.
Air batteries are again one of my cousin worked in the European Union project for lithium air batteries. So last time I checked with him, it's still a lab rat. So it will take a lot of time for a battery technology to come to mainstream, because you proving a technology in a lab is okay. So that's a very small amount of production, maybe a batch production of 25 cells, maybe 30 cells. That's one part. And it has to complete a lot of safety checks, safety trials, application level testing, life testings. All this test, it has to finish it inside the lab. And then it goes for limited series production, and out from the limited series production it will go to application level pilot testing in the vehicles. Now once it goes to limited series production, we can understand that how much efficiency and how much production rate we can achieve, and what is the production process we have to use in the vehicle in these batteries, and how much safer they are to produce, and how much cost it will take to produce these cells. And the pilot test will give you an understanding how safe these batteries or cells in the vehicle. And then once all this test completes and the battery gets certified for the use of automobile applications, then the production rate has to increase. So again, I'm saying gigawatt hour scale is needed for automobile manufacturing. You cannot produce batteries in megawatt scale. You need to scale it up to gigawatt level. So a 5 gigawatt is a minimum ideal capacity. So a 5 gigawatt hour should be needed to support a good automobile industry or multiple automobile manufacturers in a local area. So up to that, it may take from what, 5 years to 7 years. It might take 7 years to get up to that point from a lab to automobile. So that's the time period. So you cannot expect a chemistry to come to automobiles tomorrow. Okay.
Yeah.
What we have is incremental increase in the battery manufacturing. For example, we are moving towards the dry coating process. So Tesla actually succeeded in the dry coating, where in the earlier days we had the cathode mixed with the adhesive, or you can say binder, and that binder with the cathode is coated on top of your aluminum foil, basically the current collector, and then it will be dried, and the binder will go as a vapor and the cathode will stick. So this binder is a toxic substance, and the toxic vapor has to be recycled. But it's not that. This mixing of the adhesive, pasting and drying, it all energy intensive, and it takes a lot of time to get the cathode material dried and rolled to the uniform thickness. While the dry coating eliminate all that requirements, eliminate the components, eliminate a process, but it was not matured. Tesla was losing the rollers because in uneven thickness of the cathode material in dry coating. I have posted it. I have an article written about it in my LinkedIn regarding the dry cathode manufacturing of Tesla, and Elon Musk was not very happy regarding the progress. They were losing cathode material, like not only cathode material but the rollers, which make the uniform thickness in the cathode material. So presently, as of the news comes, I'm hearing that they succeeded in the dry coating method, which will reduce the number of process, number of components. So the cost will be reduced, particularly in the 4680. Okay.
Participants,
So
if the session extend for another 10 minutes, there is no issue for you, right? Please.
No issue, sir.
No problem, sir. No problem.
Okay. Continue, Dinesh.
It's a very interesting. Continue, sir.
Yes.
okay, thank you very much. So presently, what we are moving towards is an 800-volt system. Presently, if you consider majority of our cars are 400-volt, and just like I said, the major efficiency loss problem is the heat loss in electric vehicle transmission, like electricity transmission. H is equal to I square RT. So if you consider H is equal to I square RT, the heat is directly proportional to square of the current. So I square. So the moment you reduce the current, you reduce the heat loss. So this fundamental understanding of energy efficiency and losses gave the automobile manufacturers an insight, which means you reduce the current, you reduce the loss, you increase the efficiency. And when you increase the efficiency, you can able to reduce the battery pack, or you can actually get a more range, more performance out of your battery. But the problem existed because the power is equal to voltage by current, voltage into current. So when you reduce the current, the power also reduces. So instead of reducing the power, or we have to reduce the current, and they were agreed on that. Now, when you reduce the current, power reduces. So instead, what they done is they increased the voltage. So from 400 voltage, we just jumped directly to 800 voltage. So if you consider a 400 voltage system and an 800 voltage system of same capacity, consider 100 kilowatt hour capacity, an 800 voltage system uses lesser current, or half the current of a 400 voltage system, making the smaller conductors, what you say, smaller insulation, lesser amount of losses, heat losses, lesser cooling requirement. Okay, faster charging capacity because you already are in the 800-volt system, higher voltage scenario. So presently, the manufacturers are trying their best to go to 800-volt. Of course, there are some safety problems because higher the voltage, you have to use higher insulation materials to prevent the current from leaking into the chassis. But ultimately, you will have a winner in the situation. Presently, the problem is not going to 800-volt, but getting the vehicle charged, because majority of the charging stations available in the country across the globe is 400-volt. 400-volt system means it can go up to 600-volt, not a problem. But an 800-volt system will have a nominal voltage around 700, 750. So the charging station may not be able to charge your car. So what the two ideas are, either you split the battery pack, just like you see in this picture. The Volkswagen idea is to, okay, if you find an 800-volt charger.
Dinesh, are you audible?
Am I audible?
Audible, sir.
Yes.
Audible, sir.
Yeah. Okay.
Yeah, I think. Okay.
Okay, fine. Okay. So if it is an 800-volt charger, the battery charges like a normal battery. While if it is a 400-volt charger, the battery junction box will split the battery pack into two battery packs. The single battery pack will be converted into two battery packs. Okay, two battery packs. So the left one will be a 400-volt system. The right one will be another 400-volt system, and they charge them parallelly. So in the battery junction box, they arranged a clever, they just have a clever arrangement of relays and switches. Basically, relay is a switch. So they arranged the battery junction box in such a way that the system measure what is the input voltage from the charger, and accordingly they will arrange the battery in series, or they will arrange the battery in parallel. And the second approach is put a DC-DC converter just before the charging system. So a DC-DC boost converter which convert 400 volt into 800 volt will be placed in the junction box. So if you have an 800 volt charger, the DC-DC converter will be idle. It will not work. The battery will be directly charged by the charging station. If it is a 400 volt charging station, then the charging current and the charging voltage go to a DC-DC converter, which is a boost converter, and it will rise the voltage to charging voltage 800 volt, 900 volt, etc., and then charge the battery. So in the near future, you're going to see these kind of vehicles. Presently, you have the 800 volt system in Hyundai Ioniq 5, Kia EV6, the Porsche Taycan. All these vehicles, the Audi e-tron GT, all these things are 800 volt systems, and they use these kind of mechanisms. Okay, while Hyundai, I believe it is using the DC-DC converter, the Volkswagen uses this strategy. Okay, and then the next battery pack method is CTP or cell to pack. So we are going out of modules. The modules are eliminated and we are using the cells directly inside the battery pack. So the problem is if you remove the modules, you can see there is no cross members in this battery pack. This is from the CATL, and CATL's CTP systems are well known and well famous. Majority of the Chinese manufacturers like this design. So this battery casing doesn't have cross members, while the cells, you can see this is the cells, and they are cooled not at the bottom, just like the normal prismatic vehicles where you have a bottom cooling. It's not cooled at the bottom. Instead, they are cooled on the side surface. And this is the cooling plates. So the cooling plates are also the cross members of this battery. That's the advantage of this. It's called a Chilin battery pack. It's not Q, it's CH when you spell it. So Chilin battery pack. So CTP 3.0 or cell to pack 3.0, third generation. So you can actually take an LFP cell or NMC cell, and then you can put the cell directly inside the casing, and then you have the cooling lines here. And this CTP 3.0 is one of the biggest blockbusters, you can say, in the CATL's lineup. Almost every Chinese manufacturers who want a very high charging speed, very fast charging batteries like the Li Auto and etc., they are using these batteries. And you can purchase this Chilin battery pack according to the charging rate you want. There is Chilin 2C, there is Chilin 3C, there is Chilin 4C. So Chilin 4C means you can charge it with 4 times the nominal current, which means within a span of 15 minutes or 20 minutes, you can charge the battery from 0 to 80%. So 15 minutes, I believe, which is the time for Chilin 4C to get charged from 0 to 80%. And it all depends on your thermal management. Okay. To reduce the degradation, the battery management or thermal management of the cell is so aggressive, and it keeps the battery at the most appropriate temperature. And that's one of the factor that happens to be the Chinese victory over the batteries. While this is the blade battery you've been asking for, there have been two types of blade batteries. One is the full blade battery, which you see, and this been in India in the BYD E6. Now the BYD E6 is discontinued and it is called EMAX 7. So in that battery pack, I remember there were 96 such cells, long cells. It's nearly 1 meter in length, nearly. I think just 4 centimeter short. 960 millimeter is 96 centimeter in length. So on one side you have the positive, on the other side you have the negative. So here the cell itself is the cross member. So it's a battery pack they designed. They designed this as a CTP, and later they designed the short blade battery, presently which is used by the Mahindra. So short blade batteries are somewhere around 500 something, 52 centimeter or 520 millimeter in length. Little bit thicker, I believe 20 millimeter or so, where the full blade battery is going to be used by the Maruti. This is the full blade is 96 centimeter long. 1.3 or 1.4 centimeter in thickness. This is just 552 centimeter long, 2 centimeter in thickness. So that's the difference in short blade and long blade. While the short blade cells, BYD actually designed it not for the electric vehicles, but for their hybrid vehicles. I believe everybody know that BYD don't have, BYD do have a lot of hybrid vehicles, and they wanted to replace the pouch cells. So they made this short blade cells to replace those batteries. But then they found out that this is a very good battery, and then they started using them in the electric vehicles. The second generation of this battery will come later this year, which has a capability of 6C charging speed. That means 6 times the nominal ampere. So if it is 200 ampere, it can charge at 1,000 ampere. So you can understand where this is going, 1,000 ampere. Okay. And one thing we have to understand, making a CTP design or cell to pack in a pouch cell is very difficult. But Renault and LG Energy Solutions are already working on that kind of a project. The electric battery manufacturer of Renault is called Ampere. Ampere and the LG is working for a CTP in pouch. Okay. So not boring you anymore. So basic integration is like this. You have a skateboard platform. This is the new generation platforms we are using. The skateboard platform basically has the electric battery in the first place. Then you have the motors placed. So this is from This is from Foxconn, uh, which is a Taiwanese company famous for making iPhones. It has a plant in Tamil Nadu, and it has also a plant in Hyderabad. I believe Hyderabad plant will be retooled for making electric vehicles. This is a contract manufacturer. They don't want to put vehicles in their brand. They want to manufacture vehicles for other companies as a contract manufacturer, just like iPhone. Okay. While the new trend is cell to chassis. That means you are incorporating battery directly to the vehicle as a structural member. So you are replacing the floor of the battery and you are just sitting on top of the battery. You are not sitting on the floor. Okay, you are not sitting on the cross members of the floor. You are directly bolting it to your chassis. So Tesla actually done the cell to chassis integration, and helping them to do that is the gigacasting. I'm not going to explain gigacasting, but basically gigacasting is now everywhere. What you see is from Xiaomi. I believe Xiaomi, you can understand it. Just started manufacturing the automobiles like 2-3 years, and they already mastered the art of gigacasting. They call it as hypercasting. Basically, it's a high pressure die casting. Huge high pressure die casting machines manufacture front, back, etc. And this is how the battery pack looks like. A structural battery pack of Tesla will be covered with polyurethane foam. That pink color stuff you see is polyurethane. So once the battery is made, they fill the battery pack with this polyurethane foam, making the connections so strong. Once the polyurethane is solidified, the foam solidify, and then nothing moves. It's like a brick. The whole battery pack is like a super hard brick. So you can understand the brick is what you are sitting on. It's not a battery pack with multiple components. It has its advantage. Number one, it is a structural battery. It can take the bending load, torsion load, etc. But it's non-repairable. If you want a repairability, this is not the battery pack you have to go. But again, Tesla has not 100%, maybe 200% trust on its own battery. While BYD goes in a different version. They want to connect the battery directly to the chassis, but they don't want to go to cell to chassis. It's called cell to body integration. So the battery packs you see from the BYD nowadays is cell to body, C to B or CTB. Okay. So you can see the full blade battery, they positioned in the uh, what you say, longitudinal direction. Okay. Where the crash goes, not on the transverse direction, just like the previous one. Okay. So this type of battery will have a very less covering from the top, and the battery directly goes to the chassis. You are literally sitting on the battery pack, but your bolting is not on the battery pack. The bolting will be on the cross members. The cross members are there. The floor cross members are there. The battery is at the bottom, but the battery do take the load. It's not a fully structural battery. It's not a just a CTP battery also. It's a between CTP and a CTC or cell to chassis. Okay.
Jinesh, do you have any idea about VinFast manufacturing of batteries and the vehicle they are going to market in India, right? Already manufacturing is done in Tuticorin, Tamil Nadu. So how they are going to do marketing in India?
VinFast, VinFast is a interesting company because in America, if you consider the share of VinFast, it's the highest fluctuating share in any automobile industry in America. So VinFast being backed by I don't remember his name, the multi-billionaire from Vietnam. They have a huge portfolio. I have to give it to them. The portfolio of products are very high. But the problem is they are not succeeded in any of the markets.
Yeah, the
I
issue is
think
marketing.
the issue is that. So they want to make their product in India, and majority of the service related, design related stuff, I believe, done by the TTL. TTL has some agreement with VinFast, and they do a lot of job for VinFast. But I don't know how much money they have to do all this thing because they are growing like anything. And a company that grows that fast and that aggressively, I don't know. Maybe there is a old school mentality inside me, but yes, until their first product hit the market of India, I reserve my opinion regarding the VinFast. Okay.
Okay. So let's go for commercial side. What commercial
So
vehicle?
commercial side is the place where everything goes in real funny things. So Tesla was the first one to really establish a vehicle there, and now the Mercedes is there in Europe. So what you see here in this picture is the e-Actros 600. So you can see three battery packs. This is one, two, three. Each battery pack is 200 kilowatt. This is 200, this is 200, this is 200. So 200 kilowatt, that's why it's called the e-Actros 600 because 600 kilowatt hour of battery is there in the vehicle, and fast charging capacity is 1 megawatt. Okay, 1 megawatt or 1000 kilowatt. And this will take the charging in 30 minutes. I think 60% of the battery can be charged in 30 minutes. So in Europe, this become the best, what you say, best technological leap in the automobile industry or heavy commercial industry. And uh, to a certain extent, Benz got 300 to 400 orders for this truck. Just like Tesla in America, they also have 300 plus orders in their book, but the manufacturing line is not able to produce that much. So, trucking industry, battery electric trucks are winning the market. And these two examples, the Tesla semi truck and the e-Actros 600. There is e-Actros 400 also, where you have four battery packs, 1, 2, 3, 4, 100 each. The e-Actros 9 is, I think, the 300 kilowatt battery pack. Then, with respect to that, you can understand. But presently, this e-Actros 600 being the pinnacle of electric truck in Europe, while Tesla Semi is the pinnacle of trucking in America. Okay. While uh, going with the motor industry, I believe few people have the thing. While the e-axle manufacturing is the key area where everybody is reluctant. In India, I believe Tata Motors is the only company that has at least a scalable design in their hand. Everyone else is purchasing their electric motors from some other company. Tata has a joint venture with Prestolite. so that they can scale their design instead of purchasing from a company. Okay. Now, Volkswagen, I don't know how many of you seen the Monroe live. Monroe was so appreciating Volkswagen design. The Volkswagen was purposefully designing electric e-axles for almost all the brands under them, and also they are selling electric motors for other brands too. And one of their famous motor is this APP 550. You can search the YouTube, just type the APP 550, Volkswagen APP 550, and you will see the dismantling of by Monroe. And he appreciated this motor so much because it is so efficient and it's a proper German manufacturing. It's clearly a proper German manufacturing. And then I will resume. Then instead of the normal winding, if you are looking for winding scenario, the winding is gone. This pull-in winding is gone, and comes the hairpin winding, which creates more efficiency, more torque, and more power in the same volume because the higher conductivity and the higher copper fill-in factor. Here you can see the two difference. This is a Volkswagen motor also. So they gone from this cylindrical wires to rectangular wires. That's why we call the hairpin winding. It looks like this. Okay. Advantage is just by changing the windings from this to this, you will get 25% more output in torque and power. So that leads to the movement. Okay. And then axial flux motors. So what you see is from a conic company called Koenigsegg. The axial flux motors are very small in nature. You can compare it with a can here. And the output is too huge for the size. So one company in India is particularly designed a traction motor, axial traction motor for trucks, which is called a Tresa Motors, TRESA. Tresa Motors is having a 300 kilowatt or 300 HP axial flux motor designed for trucks. So you can go and check that out. But in the later years, you're going to see hub motors or in-wheel motors in electric vehicles, where transmission or e-axles will be an old story. You can connect
From
the
Israel company is manufacturing this motors, right? Israel is doing the projects in wheel-based.
Israel do a lot of projects, but what this company, this Lordstown being bankrupted. This is an American company. This company was purchasing motor from Elaphe, ELAPHE, I think. Elaphe was actually the motor manufacturer for this company, and I believe the Foxconn already absorbed this company, Lordstown. They bankrupted, and their factory now being absorbed by Foxconn. So you can see that there is no what you say axles. Instead, there is three wires. Okay, so this is very easy to establish. And another company which work on this kind of motors is Deep Drive. And this is a German company. And last time I heard from them is BMW is working with this company for making in-wheel motors. These are not axial flux motor. You have to again understand this is not an axial flux motor. This is a common radial flux motor, but it's an in-wheel motor. You place it at the stub axle. Okay. And if you go to the Deep Drive website, you can find n number of different models with respect to the rim size. Okay. You can bolt them directly into it. Or if you are an LCV manufacturer, Schaeffler had you covered. Schaeffler is a old manufacturer. It's a reliable manufacturer in the past. Okay. So they have this thing covered with you. So this is a 14-inch system. And then you can actually put it them together in the stub axle. It needs a separate inverter. Unlike the Deep Drive, you need a three inverter for this. Okay. While charging, I understand you have some things. This is the megawatt charging system here. And then the megawatt charging system can actually pump around 1.25 megawatt of power, and they can go up to 3.75 megawatt. You can see the voltage and ampere. And this is the new stuff here, which is the swappable battery. And what you see is the CATL, Chinese giant CATL doing the swappable battery. And on the right side, you can see the award-winning design of their swappable battery, which is called the Choco SCB. And it looks like this. And it is actually a copy of the Fiat design in 2010 or 2009. Fiat had a modular swappable battery pack design, and CATL actually copied that design because Fiat was not using it anyway. So you can actually have 2 or 3 battery packs. So if you purchase the vehicle, you can have one battery pack, and then you can rent a battery pack. Then after driving, you can give that battery pack back to the company, pay a rent. So this kind of innovation is there. And not only for cars, they also done it for trucks. So what you see is Baidu, which is the Google of China, associated with CATL for trucking division. And they have actually started the swapping of truck batteries. Okay. So thermal management. So particularly, I'm focusing on the hot topic, which is the BYD's 1 megawatt charging system. So what you see here in the picture is the 1 megawatt charger, and supporting it is the battery pack. You need a battery pack to support, because if you take 1 megawatt out of the grid will suffer. Okay. And the nearby industry will suffer. So instead, the system is supported by the battery packs, and the battery packs are supplying, or what you say, assisting the charger to do the charging. And the charging profile you can see here. The charging happens. I have a detailed article written in the LinkedIn. You can go and check this out. From 8% to 26% only, it charges at 1000 kilowatt or 1 megawatt. And within 5 minutes, or the charging was from 8% to nearly 62%. And the range added was 372. Helping that is the semi-blade battery or short blade battery with top and bottom cooling with refrigerant, not water cooling, refrigerant based cooling, which is a little bit tricky to do. It's little tricky to get the refrigerant because you may overcool the battery. Okay, if you don't try it properly, you may overcool the battery. But it's not a new stuff in automobile. BMW actually mastered that in the BMW i3 by 2011 or 12. Okay, so this is there with the system. Okay. Yeah, with that, I conclude the system. Thank you for listening so patiently. And yeah.
Yeah. This charging area, the discipline of charging, how it is evolving now. We talk about many manufacturers declaring that they're going to come out with charging things. 600. I'm going to even Hyundai said that all over India they're going to install about 600 stations. But really, we do not see much of activities happening. How it is going to evolve? Because now you said that this 400 volts is going to get upgraded to 600 volts and all. So do people going to wait for that, or they will for the current contemporary vehicles should we not have more stations?
See, presently, the charging stations is revolving around 400 volt only, because your budget vehicles are still on 400 volt.
Yeah.
So if you consider the Mahindras, they are still 400. Tata is still 400. The Creta, they are 400. So budget vehicles will be in the 400 category. They will continue to be in the 400 category. The problem going to be, or the changes that going to come is plug and pay. That's the new term in the air, where you don't have to carry anything. You don't have to carry a credit card. You don't have to carry your mobile phone, scan the QR code. Instead, the manufacturer will introduce a wallet. In America, it is there. The manufacturer will introduce a wallet, and the manufacturer will pay for the what you say,
Charging.
charging to the charge station operator. For example, you in India, consider you are a Tata operator. Tata is actually trying to do that. So when you connect the plug, maybe Xeon charger you are connecting, it's not you paying directly to Xeon. Instead, you have a wallet in Tata Motors, and the Tata Motors wallet will be used by Tata Motors to pay for your charging to Xeon. So you don't have to carry this RFID cards, credit cards, then scan the
Apps,
QR
mobile
code,
apps,
etc.
nothing. Yeah.
Yeah, so that is what going to be the next generation of charging systems in India, and it might take some time because you have to build the what you say payment methods. Okay, you need to seamlessly connect and then start payment of the system, but it will happen because that's a area or that's a pain point of electric owners. You have to have multiple what you say subscription of charge station operators. So the manufacturers is going to come up with something like a wallet.
And also, Jinesh, in Kerala, how we have more number of charging stations compared to other states in India. Where because I can see from Trivandrum to Valaya, there are a lot of charging stations. So how it is, how government
Yeah,
is supporting for this?
being a Kochi person, I stay in Kochi. So around me, in a 5 kilometer radius, I have around 13 to 15 fast charging stations. Uh,
Yes.
I don't know how much it is being utilized, but as the number of vehicles increases, you will see it is being utilized. Yeah, see, right across my house, means my flat, there are two 30-watt fast charging station, and if I go to 1 kilometer, 2 kilometer away, I have 60 kilometer, I have 20 kilowatt, 60 kilowatt charging stations. Then I have AC charging stations. I have at least six or more charging stations that are rated to 60 kilowatt or more around me. So in Kerala, the
Also, I can
charging
see the
stations are
poles also
huge.
everywhere.
Y-
I can able to see the poles in your government area. Means government electricity board. There are a lot of poles for charging the three wheelers, two wheelers.
Yeah, that's by the company called Charge Mode. It's a very famous company in Kerala. It's a startup company which actually worked with the local electricity supplier, which is Kerala State Electricity Board, to use
Okay.
the electricity post for charging station. These are 3.4 kilowatt AC charging units for two-wheeler and three-wheelers.
Reservation of the users, the consumers, has always been, being for fast. The world itself have become fast. So people, I see few people who wait for charging. They expect like in a jiffy the battery should get charged. So how the technology is moving towards that? Will it happen? Say, for example, a standard car battery gets charged in 10 minutes or 15 minutes, like you fill up petrol or when you fill a fossil fuel, it doesn't take more than 3 to 4 minutes. Do we have any chance of reaching that point, or
See, the battery charging is now the most focused area instead of battery life because we already have a battery life that can surpass 10 years. If you find the owner's manual of the BE6E, the battery warranty even for a commercial application is 10 years. Mahindra say 10 years or 2 lakh kilometers in the owner's manual. So Mahindra is confident that the BYD cells will last for 10 years. And most of the companies do understand that a general user will have a good amount of health. Then the fast charging is a completely different stuff because your thermal management system is a key. So for example, if you have a 20 kilowatt battery pack, that 20 kilowatt battery pack, how it is thermally managed, that gives you the fast charging capacity plus the cell. The cell has to have the fast charging capacity. For example, you want to leave by within 30 minutes, maybe 15 minutes, you need a 4C chargeable cell. So if the cell is 100 ampere, you need 400 ampere charging current going into the cell. And that kind of cell technology is not cheap as of now. Maybe in the future it will be cheap, but presently it's not that cheap. So getting them into a budget car is going to create a higher cost for the vehicle itself, which the manufacturer don't want. And in India, it's that it's a highly value-based market,
Yeah.
and manufacturer don't want to screw themselves up.
Yes. Yeah. Correct.
So I mean,
Hello.
there is nothing. Yeah, please.
So thank you for the informative session, first of all. I have one question regarding the battery as a service. So from past 3 months, consecutive 3 months, Tata's sales has been dropped for the passenger vehicle. And MG has taking up with the battery as a service because they are certainly downgrading the, what you can say, upfront cost of the passenger vehicle for the EV, of course. So what do you think, what will be the future for the battery as a service in passenger vehicle as well as in the commercial and all vehicles?
See, what MG is doing is not a battery as a service. You can say battery as a loan, because in a battery as a service, the battery will be never you cannot own the battery. Okay, what Honda is saying, the Honda two-wheelers, the Honda Activa is what the original battery as a service, and where you cannot own the battery. You have to pay a subscription fee all the time, every time. You are only owning the vehicle. What MG is saying, it's a battery as a loan. So you pay 10 lakh and the remaining 3 lakhs or 4 lakhs, you can pay as a separate loan. That is what MG is saying. And it's not about the battery as a service or a battery as a loan that makes the MG wins or a winner. It's the value. So for 15 lakh, you are actually getting a Creta size car. It's a Creta size car. You can understand the size of the car is too huge, and it's a basic electric platform.
Yes. Yeah.
And unlike Tata's car, which had a lot of software related issues and other problems, it's ultimately next one is a sub 4 meter car. You understand that part, right? So
Yes.
a sub 4 meter car for 15 lakh and a 4.2 meter car for 15 lakh. Which one will be more suitable? So people see value. It's not about the battery as a loan or something like that. Battery as a service is not even started in India. Honda is the first one to start, and I wonder whether they will succeed in that because the subscription fee is too high.
Okay. Yeah. Thank you. Got it.
Arvind?
Yeah. So I think we can close this session. So if you have any doubts, please put it in the chat box.
Yeah, I have a last question, Jinesh. Can I
Yeah,
ask?
please.
Yeah, it's on a moral thing. With all tom-tomming about the green energy, blah blah blah. What is the virtual thing that is happening in manufacturing an electric car, which I have read in few articles that it is much worse than a IC engine, effect on environment. Does it really happen, or is it that way, or do we really contribute to it?
It's people. Yes, it's to a certain extent. What you say is correct because electricity comes from coal power plant. Nearly 50 to 52% of our grid is coal powered or fossil fuel powered.
Fossil fuel, yeah.
But you have to understand that the petrol and diesel is not raining from heavens.
Yes.
So you have to dig the earth, pump the petroleum, and then ship it through oceans and pump it to refinery where you have to thermally crack it, then store it in containers, send it via trucks, push it into the fuel pump, and then push it to the fuel tank. So this much amount of energy is spent over petroleum to convert it into petrol, and then you have to burn it, and the exhaust gas is already going out of the tailpipe. So this much amount of pollution is happening, and I would request you to refer the International Energy Agency's study regarding the life cycle emission of electric vehicles and IC engine vehicles. And that's an open study. It's in 2021. They studied an IC engine car and a electric car for the life cycle emission. So it clearly said the electric vehicle have a very good advantage over the IC engine vehicles. I repeat, International Energy Agency study life cycle emission of electric and IC engines 2021.
Okay. In fact, my question was not after manufacturing. I am asking about during manufacturing. How much?
Yeah, same.
Same only. Huh?
They classified it into 4 areas:
Okay.
materials, manufacturing, power generation,
So everything
and
is included.
direct.
Okay.
Everything is included.
Included. Okay. Thank you.
Yeah.
Thank you very much.
Thank you all. Thank you very much for
Thank you.
being with me.
Thank you.
Thank you, Aravind.
Yeah,
Thank
Dinesh,
you.
thank
Yeah,
very
thank
much
you.
for taking
Thank you
part
very
in this.
much.